Okay, so can you please tell me about yourself and your recent project?
Yeah, sure. So, hi. So, I have around 2.4 years of experience in software development with a primary focus on Java, Spring Boot, and microservices. And my technical expertise includes Java, Spring Boot, REST APIs, SQL databases, and NoSQL databases such as MongoDB, and basic exposure to cloud technologies. And in my current role, I am responsible for developing and maintaining backend services and also creating APIs and integrating microservices. And along with that, I also work on the optimizing the database queries and supporting the production issues. And coming to my project, so in my recent project, I have been working on a microservices based enterprise application where I develop Spring Boot services that work with both SQL and NoSQL databases. And I have also contributed to the performance improvement and feature development. And I also collaborate with cross-functional teams and participate in the deployment and support activities like UI people or testing people. So I do collaborate with them as well. So yeah, so this is what is all about myself and about my recent project.
Okay, but what exactly is your project?
Yeah, so currently I'm working on an e-commerce order management system. So that is built on Java, Spring Boot, and microservices architecture. And the application basically allows a customer to browse products and place order and make payments and track deliveries. And to achieve this, the system is divided into multiple microservices. Like we have customer service, order service, product service, payment service, inventory service, notification service. So these kind of services we have, and these microservices basically communicate with each other using the REST APIs. And for asynchronous communication, we are using Kafka. So for data uses, we use PostgreSQL as a primary SQL and database, and MongoDB also we are using for storing the product catalog and audit related data. So yeah, so we are using this, and apart from that, we are also using Redis for the caching, frequently accessed information to improve the application performance. So yeah, so my responsibilities in these include like in developing the REST APIs, using the Spring Boot, and implementing the business requirements and integrating different microservices, and also optimizing the database queries. And additionally, I have some exposure to cloud environments also. So we also participate in the deployment of the application, and I work with CI/CD pipelines for the automated builds and deployment process. So yeah, so this is what is all about my recent project.
So why you are using both SQL and NoSQL? What is the need of both?
Uh, yes, so in our project we are using both SQL and NoSQL because they solve different types of problems. So for transactional data such as customer order payments and inventory information, so for all these we are using SQL databases like PostgreSQL. So these modules require strong consistency and also like complex joins and relationships and all. So we are using this PostgreSQL. And for example, like when a customer is placing the order, then we need to ensure that the order details, payment status, and inventory, all the updates are handled reliably. So the SQL is better choice in this case. But on the other hand, we also have no SQL, like we are using MongoDB especially for that. So that we are using for the product catalog data. So product information also we are storing in that. So for example, let's say when a mobile phone may have a RAM, storage, and battery specification. While let's say we have some different item, let's say shirt is there, so that may have size, color, and fabric details. So you see the description of both of the items are different. So storing such flexible and changing structure in a relational databases, that would require like maybe many tables and frequent schema changes. So MongoDB allows us to store this data in a document format. So that makes it more flexible and easier to scale. So that is why we are using this SQL and NoSQL both. Yeah.
Hmm. Okay, so in cloud, what exactly you have worked on?
Yeah, so I have some exposure to cloud environments. So although I am not directly involved in cloud architecture design, so in my current project, like our microservices are deployed on cloud infrastructure, and my involvement includes in that basically in monitoring deployments and validating application health and checking logs, and along with that I also do troubleshoot the issues and manage the environment specific configurations whenever required. So in that I have worked on with like deploying Spring Boot applications through the CI/CD pipeline, and also managing the application configurations using the environment variables and configuration files, and also monitoring the application logs and troubleshooting deployment issues. So I also do check. I check the like health and application metrics. So yeah, so all these things I have done, and I have also collaborated with the DevOps team during the release and production deployments. So like if any deployment related issue occurs, so I help in analyzing logs and validating configurations and ensuring that the services are up and running properly. So yeah, so until this extent I have worked on. So yeah.
By the way, which cloud platform you have used?
Yeah, so I have used primarily AWS. So I have worked with services from the application perspective, such as like EC2 for hosting application and S3 for file storage. So and CI/CD pipelines I have used for deployments. So yeah, and also CloudWatch I have used for monitoring and logs. So yeah.
Suppose a microservice is not working after deployment. How would you investigate using CloudWatch?
Yeah, so if microservices is not working after deployment, then my first step would be like to check the application logs in CloudWatch. So I would log into AWS console and navigate to CloudWatch and open the relevant logs, log groups and latest log stream for the microservices. And then I would look for any startup failures or any configuration issue or any database connection related errors. So any kind of errors can be. So I would first I would also verify like whether the application has started successfully and check if the recent code changes or deployment configurations could have caused the issue. So that also is like most of the time we see the that kind of issue, and we can roll back the older code, and we can again check the new changes. And additionally, like I would also review the CloudWatch metrics and alarms to see if there are any unusual spikes in the error or CPU usage or memory consumption. So yeah, so based on the logs and metrics, we can identify the root cause, and either we can fix the issue, or also we can coordinate with DevOps team to identify the issue and fix it. Yeah.
Can you tell me what other types of dependency injections are there?
Yeah, so in Spring Boot, there are mainly three types of dependency injections. So one is the constructor injection, then setter injection, and then the field injection. So these are the three types. So constructor injection is like most preferred approach because it ensures that all required dependencies are provided at the time of object creation, and it makes the class like easier to test and promoting immutability. And setter injection is used when a dependency is optional or may need to be changed after object creation. And then we have field injection. So field injection directly injects dependencies into a class fields using the rate of auto add annotation. So that makes the code concise, but is generally not recommended because like it makes unit testing more difficult and hides the class dependencies. So yeah, so in most enterprise applications, constructor injection is considered the best practice due to the better maintainability and testability.
So, what happens if a dependency is not available?
Yeah, if dependency is not available, then I think Spring throws a bean creation exception. That happens during the application startup itself actually, because it cannot satisfy the dependency. So yeah, so it will throw this exception.
Okay, so what is inversion of control, IOC?
Yeah, in version of control or IOC, like it is a design principle where the responsibility of creating and managing objects is transferred from the application code to the Spring container. And instead of developers manually creating objects using the new keyword and managing their dependencies, Spring automatically creates, configures, and manages these objects. Okay, so these objects basically are known as the beans. So this helps in reducing the tight coupling between the components and makes the application like kind of more maintainable and testable. So yeah, so that's what is the dependency injection is. Yeah.
And how does Spring know which object to inject?
Yeah, so Spring defines the object to manage by scanning classes annotated with the different stereotypes, like we have add rate of component, add rate of service, add rate of repository, add controller. So all these are basically, these annotations are the stereotype annotations. So during the application startup, Spring Components scanning mechanism detects like these classes and creates beans for them in the application context. So when a dependency is required in another class, then Spring looks for a matching bean based on its type and injects it automatically. So yeah, so if multiple beans of the same type is available, then it again applies a different approach for that. So yeah.
Hmm. Okay, but what approach it applies if multiple beans of same type is there?
Yeah, if multiple beans of same types are available, then Spring first tries to resolve the dependency by type. So since like more than one matching bean is found, so it cannot decide like which one to inject, and it throws like no unique bean definition exception. Okay, so yeah, so to resolve this, we generally use either add rate of primary or add rate of qualifier. So yeah, so with primary we mark one bean as the default choice, and Spring injects it like whenever there is an ambiguity. And with qualifier we explicitly specify the like exact bean that should be injected. So that can be done using like annotation add data qualifier. And if both are present, then add data qualifier takes the precedence, because like it provides a direct instruction to Spring Boot which bean to use. So yeah, so that is how we can resolve this.
Okay, and what is the difference between bean factory and application context?
Yeah, so both Bean Factory and application context are Spring IOC container responsible for creating and managing beans only. So Bean Factory like is, we can say, is a basic container that provides fundamental dependency injection and bean management capabilities, and it follows like kind of a lazy initialization by default. So that means that like beans are created only when they are requested. And on the other hand, like application context is an advanced container that extends bean factory and provides additional enterprise level features, such as like event publishing or internationalization or annotation based configuration support. So all these can be there, and even Spring AOP is also like all these. So in most of the modern Spring Boot application, like application context is used internally, and is like that is a preferred container, because like it offers more functionality and better support for the enterprise application. So
Okay, okay. And what is circular dependency?
yeah, a circular dependency basically occurs when two or more Spring Bean depend on each other. So creating a dependency cycle basically. So for example, let's say if Bean A requires Bean B to be created, and again B also requires bean A to be created. So in that case, Spring is unable to determine like which bean should be instantiated first. So this situation actually is known as the circular dependency. So circular dependencies are like most commonly seen with the constructor injection, because like both beans need like each other during the object creation. So that can lead to application startup failure. So yeah, so to resolve this issue, we can redesign the application to remove the dependency cycle, and we can use add the rate of lazy annotation to defer bean initialization, or in some cases we can use structure injection instead of constructor injection. So yeah, so that's what is the circular dependency. Yeah.
Okay, so suppose dependency added but bean not created. So how to debug auto configuration?
Yeah, so if I add a dependency, but the expected bean is not getting created, then I would first enable Spring Boot's debug mode by setting like debug equal to true in the application.properties, and this generates the conditions evaluation and report during the startup. So that helps to identify like why a particular auto configuration was applied or skipped, and then after that I would check the whether the required dependency is present in the class path and verify if all the prerequisite classes are available. And I would also review any conditional annotations such as like anywhere like add data conditional on class, conditional on missing beans, or conditional on property, anything like that is there, because like auto configuration may be skipped if these conditions are not satisfied. Okay, and additionally then I would also check the like application startup logs for bean creation error or exception. So if Spring Boot actuator is enabled, then I can use like endpoints such as actuator beans or actuator conditions. So yeah, so these we can use to inspect the beans loaded in the application context and understand like why a specific bean was not created. So by analyzing all these logs and conditions, so we can like identify the main issue.
Do you have any idea about like what causes HTTP 415 unsupported media type?
Yeah, so HTTP 415 unsupported media type occurs when like the content type of the request sent by the client does not match the content type expected by the server. So in Spring Boot, this typically happens when a controller is configured to consume a specific media type, such as like application JSON, but the request is sent with the different content type header. So let's say it was sent through the, let's say, text plain or maybe application XML. So as a result, like Spring is unable to process the request body and returns like 415 error. Yeah, so troubleshoot this, we can use and we can verify request header and check the controllers like add the item request mapping and post mapping, boot mapping notations, whatever we have used, and ensure that the content type is specified by the client that also matches to the like API X that is expecting. So yeah.
Can you tell me what challenges have you faced while working with microservices?
Yeah, so one major challenge is like is managing communication between services and handling failures like adequately. So like network latency, service downtime, and timeout issues are very much common concerns in distributed system. And we address these challenges like using the proper exception handling, timeout configurations, or retry mechanism, or circuit breaker patterns. So we apply all these to handle those. And another challenge is like is the debugging the request across the multiple services. So which is why like for that purpose we have used like centralized logging and distributed tracings so system. So that is very much important. So yeah, so these are challenges and also like how we handle it.
Okay, how do you handle failures in a microservices environment?
Yeah, so in a microservices environment, like failures are inevitable, we can say, because services communicate over the network. So to handle failures, we implement timeouts to prevent a request from waiting indefinitely, and retries for the temporary failures, and also circuit breakers to avoid the repeatedly calling the unhealthy services. And we also provide like fallback responses, what like whether the appropriate it is there or not, whatever is required, and so that the users receive meaningful information even the like dependent services suppose temporarily not available. So yeah, so we can add some fallback methods, and that method, what in that method whatever would have been written, so that will be returned as the response in case of failure of the any specific microservices.
Okay, and what is API gateway and why is it used?
Yeah, API gateway, like it is a very commonly used in the microservices, so that acts as a single entry point for all client requests. So like instead of calling directly multiple microservices from the client, so they communicate with API gateway. So the clients communicate directly with API gateway. So that routes request to the appropriate services, and it also provides like additional features such as like authentication, authorization, rate limiting, logging, and request routing. So all these are done at the API gateway level itself. So yeah, so this basically simplifies the client iteration client interaction, we can say, and centralizes the common concerns. Yeah.
For logging, which tool you use? And also, can you please tell me the steps?
Yeah, so in our project, we use SLF4J as a logging API along with the logback as the logging implementation. So that comes as the default logging framework in Spring Boot. And for centralized log monitoring application, logs are collected and made available through the CloudWatch, and this basically helps us like in troubleshooting issues and monitoring application behavior and all. So if suppose if any issue is reported, then I first identify the affected microservices, then I log it in the AWS console and navigate to the CloudWatch. Okay, so from there I open the logs section and select the relevant log group corresponding to the microservices, and after opening the latest log stream, then I check logs around the around the time when the issue occurred, and search for the exceptions or any kind of error messages. Okay, and also we can check the request IDs or any timeout error or any database connection issue is there. So anything is there, we can check in the logs. So that is how we can check, and we can take the action accordingly.
Okay, so do you know what is database per service pattern and why is it recommended?
Yeah, in microservices, like each service should ideally own its database instead of sharing a common databases with other services. So, like this is known as database per service pattern. So it ensures like loose coupling because changes made by one service do not directly impact other services. Okay, and it also allows a team to choose the most suitable database technology for their service requirement and scale database independently. So yeah, so that is what is the database per service pattern, and this is why it is recommended. Yeah.
Okay. What is the N plus 1 problem in GPA and how would you fix it?
Yeah, the n plus one problem like is a common performance issue in JPA. So that occurs when like fetching the related entities. So for example, if I fetch a list of 100 orders, then JPA may first execute one query to retrieve all orders and then execute an additional query for like each order to fetch its associated customer or items. So as a result, like instead of executing a single optimized query, the application ends up executing like maybe like 101 queries. Okay, so that can significantly impact the performance. To solve this issue, like we generally use like fetch join in JPQL. So like entity gaps or batch fetching, so that the related data can be loaded efficiently with fewer database calls. So yeah, so that is what is the n plus one problem. Yeah.
Okay. So, can you tell me what is the difference between eager and lazy fetching?
Yeah, sure. So like eager and lazy fetching basically determine like when related entities are loaded from the database. So in eager fetching, like associated entities are loaded immediately along with the parent entity, like regardless of whether they are needed or not. And in lazy fetching, like related entities are loaded only when they are explicitly accessed in the application. Okay, so coming to like in the most real world applications, like lazy fetching is generally preferred because like it avoids like unnecessary database queries and it improves the performance. So it will only be fetched whenever we explicitly need it, right? So that's the main difference. So yeah, so basically it all depends on the business requirement and data access pattern how we want to do that. So
Mm, fine. So, can you explain the different transaction propagation types in Spring?
yeah, so Spring provides several transaction propagation behaviors that define how a method should participate in an existing transaction. So the most commonly used propagation is required, like which is like which joins an existing transaction if one is available, or it creates a new one otherwise. Okay, so like and then we have requires new underscore new, so that always creates a new transaction and suspended, and it suspends basically suspends the current one. So that's another one, and then we have supports, so that executes within an existing transaction if present but can also run without the one, and then we have not supported. So that suspends any existing transaction and executes non transactionally. Okay. And then we have I think mandatory is also there, so that requires an existing transaction and it throws an exception if it does not exist. Okay. And then never works opposite to like mandatory, and it throws an exception like if a transaction already exists. And then we have nested, so it creates a nested transaction within the current transaction and allows partial rollbacks without affecting the entire transaction. So yeah, so these are the different types of transaction propagation in the Spring. Yeah.
Okay. And how would you implement optimistic locking in JPA?
Yeah, optimistic locking is used to prevent data conflicts when multiple users attempt to update the same record simultaneously. So in JPA, it is implemented by adding a field annotation with at the rate of version in the entity. And whenever a record is updated, then JPA automatically checks the version value. And if another transaction has already modified the same record and changed the version, then JPA detects the conflict and throws an like I think optimistic lock exception or something like that. So this approach is useful in application where like concurrent updates are relatively infrequent and we want to avoid the database locking over it. So yeah.
Okay. So suppose you have developed a batch job that inserts around 10,000 records into the database, but during testing you notice that the processing is taking much longer than expected. How would you investigate and optimize the performance?
Yeah, so if I notice that the insertion, like inserting 10,000 records is taking longer than expected, then I would first check like how the records are being persisted. Okay, so one common issue is inserting record one by one, like which results in a large number of database round trips. So to improve performance, I would like first enable the JDBC batching so that like multiple insert statements are grouped together and sent to the database in batches. Okay, and instead of calling like save method repeatedly for each record, we can use actually save all wherever appropriate and wherever we can do that. Okay, and apart from that, I would also like periodically I we can call flush. Okay, flush method and clear method on the persistence context to avoid like excessive memory usage and prevent the entity manager from holding like thousands of managed entities. So these methods are used for that. And additionally, I would also like review like database indexes and monitor SQL execution times and use the batch size configuration to find the like optimal value for the specific database environment. Yeah, so basically these optimizations usually we can all together we can check, and this will lead to significant improvement in the batch processing performance. Yeah.